Hi everyone. So this is a lecture for operating system structure, chapter 2. Yeah. All right. Okay. Objective of this module to describe the services and operating system provides to users, processes, and other systems. Next, to discuss the various way of structuring an operating system. To explain also how operating system are booted. Okay, these are the objective of this module. All right. Next. So 2.1 operating system services. The operating system provide an environment for the execution. Yeah, 1 second. Okay, operating system provide an environment for the execution of program. So operating system provides certain services to programs and also users, yeah, for those programs. Basically, two types of services: set of operating systems services provides functions that are helpful to the user. And then another type is set of operating system function for ensuring the efficient operation of the system itself via resource sharing. OS services helpful to the user. One of the many OS services is user interface. User interface, almost all operating systems have a user interface. This interface can take several forms. First, CLI or command line means use a text command and a method for entering them. Says a keyboard for typing in command in a specific format with specific options. Next, regarding graphics, yeah. So another form is a graphic user interface, GUI. So the interface is a Windows system with a pointing device to direct I/O, choose from menus, and make selection a keyboard to enter text. Next, batch interface. Command are commands and directive. Yeah, directive. To control those commands are entered into file, and those file execute. Yeah. Some system provide two or all three of these variations. So this is the figure regarding operating system services. So you can see that this is the form of the layer, for example, yeah, the form of layer. All right. So this is what you can see here is a layer, yeah, the layer. On top, you can see user and other system program, and next we got user interface. So means that user interface providing, yeah, providing what? A services, yeah, providing a services. Okay, providing a services to the we call to the system. Okay, what you can see user on the top here. There's a user and other system program and hardware. So of course, okay. So user interface is part of the OS. So try to communicating, okay, between user and also the system itself. Okay, if you can remember that last lecture, I told you that OS is a let interaction. They will let the interaction or help the interaction between user and also hardware. So more specific inside the operating system, we got this kind of the architecture. So user interface itself is a top one. Okay, so it will communicate to all the system existing system call in the operating system in order to execute each of the instruction. All right. So later I will explain more on the following slide. Okay. All right. So what is the command interpreters or CLI? CLI allows user to direct enter commands to be performed by the operating system. Some operating system include the command interpreter in the kernel. Yeah. So some operating system, okay, such as Windows and Unix, treat the command interpreter as a special program that is running when a job is initiated or when a user first logs on. Yeah. On system with multiple command interpreter to choose from, the interpreter are known as a shell. Okay. The main function of the command interpreter is to get and execute the next user specification command. Sometimes command built-in, sometimes just name of programs. If the latter, adding new features does not require shell modification. All right, so that's regarding CLI. So this is one of the what we call that just now, the shell. So it's a Bourne shell in Solaris. Solaris is another example of the operating system. Yeah, they're using a Unix environment, the language. If you're familiar with Linux, so the language they will use, syntax almost same. All right, not like Windows. Yeah. GUI or graphical user interface. User friendly, yeah, user friendly desktop metaphor interface. Usually mouse, keyboard, and monitor. So this is quite familiar for us. Yeah. Icons represent file, program, action, etc. Various mouse button over object in the interface cause various action. Provide information, option, execute function, open directory, known as a folder. Invented at Xerox PARC, yeah, PARC. The many systems now include both CLI and also GUI interface. Microsoft Windows is GUI with CLI command shell. Yeah. Apple Mac OS is Aqua GUI interface with unique kernel underneath and shells available. Unix and Linux have CLI with optional GUI interfaces like CDE, KDE, and also GNOME. So touch screen interfaces. Touchscreen devices require new interfaces. Mouse not possible or not desired. Yeah. Action and selection based on gesture. Virtual keyboard for text entry. And also some voice command. In order to using this. Yeah. Okay, this is regarding touchscreen interfaces. So the Mac OS, OS X GUI. So this is example. It's a graphical user interface for Mac OS. Yeah. So there's a Mac OS X means the version, the name of this Mac version. Yeah, one of the name. So system calls. Programming interface to the service provided by the OS, typically written in a high-level language, C or C++. Mostly accessed by program through a high-level application program interface or API rather than direct system call. The most common API are Win32 API for Windows, POSIX API for POSIX-based system, including virtually all version of Unix, Linux, Mac OS. Java API for the JVM or Java Virtual Machine. So that's most common API available. Okay, the most common API available in the market. Note that the system call names used throughout these tags are generic. Example of system call. System call sequence to copy the content of the content of one file to another file. Yeah. So source file and then goes to destination file. So here are the content. Okay. Example of standard API. So this is example. You can access, if you look as an example of standard API, consider the read function. Here that is available in Unix and Linux system. The API for this function is obtained from the man or manual page by invoking the following command: man read on the command line. The description of this API appears below. So this is the one. A program that uses the read function must include this unistd.h header file. SD file define the size and size as size t and also size and size underscore t data type, among other things. The parameter passed to read function are as follow. For example, integer and also a buffer, void buff, a buffer where the data will be read. Size t count the maximum number of bytes to be read into the buffer. Unsuccessful integer one. Okay, unsuccessful read. Yeah. The number of bytes is returned. A return of 0 indicate end of file. If an error occurs, read function return -1. All right. Type of system calls. System call can be grouped roughly into 6 major categories. We have process control, file manipulation, device manipulation, information maintenance, communication, and also finally protection. So here are the name of the function. Process call in Windows, this, yeah. And in Unix, similar with the create process, they use for fork. And for exit, same exit but different syntax. And here for wait for single object in Unix, just a wait bracket. So this is the kind of system call available for Windows and also the Unix for each of these category. Yeah, device manipulation, information maintenance, communication, and protection. All right. So this is just an example. It could be more actually. Yeah. All right. System program. System program provide a convenient environment for program development and execution. Some of them are simply user interfaces to system calls. Others are considerably more complex. They can be divided into file manipulation, status information sometimes stored in the file modification, program language support, program loading and execution as well, communications, background services, and finally, application program. Most users view the operation system is defined by system program, not the actual system call. Yeah. Operating system structure. Various ways to structure an operating system Yeah. Monolithic structure mean simple structure like MS-DOS. More complex Unix, more complex other than Unix is Linux. And then layer, which is an abstraction. So microkernel, yeah, use a Mac language. Yeah, all right. Simple structure MS-DOS. MS-DOS returned to provide the most functionality in the least amount of space. MS-DOS was limited by hardware functionality, not divided into modules. Although MS-DOS has some structure, its interfaces and levels of functionality are not well separated. More complex regarding Unix. Unix, the original Unix operating system, had limited structuring and was limited by hardware functionality. The Unix OS consists of two separable parts: system program, and next is the kernel. So the kernel itself consists of everything below the system core interface and above the physical hardware. Provide the file system, okay, CPU scheduling, memory management, and other operating system function. A large number of functions for one level. So this is a unique, traditional Unix system structure. Yeah, on the not early age but traditional. Yeah, so you can see user, similar thing, user, and the lowest part is the hardware. Okay, similar like open or SI layer, all the layers similar. They will works by layer. So you can see shell and command compiler interpreter and library after user. Yeah, and system core interface to the kernel. We have three parts here. All right. Okay, kernel. And also kernel interface to the hardware. Okay, from kernel to the hardware, we got how many? Terminal controller, terminal device controller, disk and tab, memory controller, and also finally physical memory. All right, this is the structure or system structure for traditional Unix. So this is system structure for Linux. Yeah. So little bit or slightly different, yeah, among, but the similar point between these two are it works as a layer. If you can see the top one is mentioned, the lowest part is the hardware, similar to the previous one also. Now I give example, the hardware, monitor hardware. Okay, they'll develop this kind of the things layer by layer. Layer by layer comes from the standard what we call this IEEE standard, I think, if not mistaken, provide the guideline. Okay, that's why you can see almost similar, they work in the layer. Okay, because based on the open OSI, open system interconnection standard, and also some standard for TCP/IP, they are all in layers. Okay, similar to this, yeah, system structure Linux and also traditional Unix. All right. So layered approach. A system can be made modular in many ways. One method is the layered approach, in which the operating system is broken into a number of layers. The bottom layer is the hardware, and the highest layer is the user interface. Yeah. Okay, that's the justification of that. Microkernel system structure move, yeah, as much from the kernel into user space. Mac example of microkernel, which is Mac OS kernel, Darwin, partly based on Mac. Communication takes place between user module using message passing. Okay, in HPC, you will see the word, what you call this, high performance or high performance parallel computing or high performance parallel computing. Maybe the second one, yeah? Okay, HPC. So that's regarding what we call this message passing. They communicate using a message passing concept. Benefit, easier to extend a microkernel, yeah, and then easier to port the operating system to a new architecture, more reliable, less code is running in kernel mode, and of course, finally, more secure. Determines perform overhead of user space to kernel space communication. Yeah. Okay, this microkernel system structure. Okay, the file system, we got memory interface, CPU scheduling, and this is the hardware. Okay, the lowest is a hardware. The top one is the end user or application. Almost similar. So here they say user mode, and we got kernel mode. Okay, last final is maybe hardware part or hardware. Yeah, all right. There's a common structure for microkernel system structure. Okay, many modern operating system implement loadable kernel module. Okay, use object-oriented approach. Each core component is separate. Each talks to the others over known interfaces. Each is loadable as needed within the kernel. Overall, similar to layers, but with more flexible. Right? Similar to layers, but more flexible, such as Linux and Solaris. Hybrid system. In practice, very few operating systems adopt a single, strictly defined structure. Instead, they combine different structures, resulting in hybrid system. Right? In hybrid system that address performance, security, and usability issues. For example, Linux is monolithic. Yeah, monolithic because having the operating system in a single address space provides very efficient performance. However, Linux are also modular, so that new functionality can be dynamically added to the kernel. Yeah, example of the structure of hybrid: Mac, Apple Mac operating system for laptop, iOS mobile operating system, Android is a mobile operating system. So this is architecture for Mac OS and also iOS. All right. Okay. So Android, developed by Open Handset Alliance, mostly Google, open source. Yeah, it's a open source. What we call this open source group or type of the. I mean Android itself. Yeah. So similar stack to iOS based on Linux kernel but modified, provide process, memory, device driver management, and also add power management. Runtime environment include core set of libraries and Dalvik Virtual Sign. App developed in Java plus Android API. Java class file compiled to Java by code, then transfer to execute, then run in Dalvik VM Virtual. Libraries include framework for web browser or WebKit, database, SQLite, multimedia, and smaller libvic. This is the Android architecture, almost similar. Yeah, there are works in layer. So the top one is application, the lowest part is the hardware, any hardware. Yeah, here Linux kernels. System boot. When power initialized on system, execution start at a fixed memory location. Yeah. So like firmware ROM used to hold initial code, boot code. Operating system must be made available to hardware, so hardware can start it. A small piece of code, for example, bootstrap loader, store in ROM or EEPROM, locates the kernel, loads into the memory, and start it. Sometimes two-step process where boot block are fixed. A location loaded by ROM code, which load bootstrap loader from this. Okay. Common bootstrap loader or GURB allows collection of kernel from multiple disk versions and also kernel option. kernel loads the system is then all right. So this regarding previous, yeah, they put your exercise. So all right, thank you.